Hello everyone. Our next topic is resistor, inductor and capacitor. In that first one is resistor. So definition of resistor is it will oppose the flow of electrons or flow of current. That means it will oppose the flow of electrons or flow of current and it will dissipate the energy in the form of heat. It will dissipate the energy in the form of heat. And formula for resistance of any material is given as rho L by A. This is ohms. Okay, the formula for any material resistance is given by rho L by A, where rho is specific resistance. Specific resistance or resistivity. For different types of materials it has a different value, and L is the length of the material and it is in meters. And next one, A is the area of the material, it is in meter square. Okay, the units of resistivity is ohm meter. So the symbol of resistor is denoted like this, R ohms. Okay, inverse of the resistivity, that is conductivity, rho is sigma is equal to 1 by rho. So this is units are ohm inverse, meter inverse. Next one is resistance of any material is depends on resistivity of that material, length of the material and area of the material. And one more parameter is there, that is temperature. Okay, resistance is the temperature dependent quantity. How it will depends? If temperature of any material increases, resistance of the material is increases, except negative temperature coefficient materials like carbon. If temperature of the carbon is increases, resistance of the carbon is decreases. Okay, for positive temperature coefficient materials, if temperature increases, resistance is increases. Here resistance is increases. Okay, so the formula for resistance is, if the depends of temperature, R naught into 1 plus alpha into delta T. This is the new value. Here R naught is the resistance of the material at 20 degrees centigrade, alpha is the temperature coefficient, delta T is the change in temperature, that is T1 minus T0. Okay, resistance of any material depends on resistivity, that is nature of the material or specific resistance of material, length of the material, next cross section area of the material or area of the material, temperature of the material, and one more thing is there, that is impurities. Impurities of the material. Okay, resistance depends on impurities present in the material, but not depends on voltage and currents. From the Ohm's law, what is the formula for resistance? R is equal to V by I. Okay, so here resistance does not depends on the voltage and current. Okay, only resistance depends on these 5 quantities. Okay, so this is the important point. Okay, next, power dissipated in the resistor. So what is the power? Power is equal to work done by time, that is dW by dt. This can be written as dW by dq into dq by dt. Okay, here dt, dq cancel, then you will get dw by dt. Here we can replace dw by dq with voltage v and dq by dt with current I. So what is the power now? P is equal to vi, or you can write this is capital letter. Power v is equal to, power P is equal to vi, and the units of power is watts. Okay, from the Ohm's law, what is voltage? V is equal to IR. Substitute this value in this equation, you will get P is equal to I square R. Okay, this is the one more expression for power dissipated in the resistor. So from this expression, what is I? I is equal to V by R. Again substitute current in this equation. So what is the power? V square by R. Okay, these are the three expressions for power dissipated in the resistor. Mostly we are using this formula. Power dissipated in any resistor is P is equal to I square R. Power dissipated in the resistor is P is equal to I square R. Now, second element is inductor. The definition of the inductor is it is the property of the material which oppose the sudden changes in the current. Which oppose the sudden changes in the current, and it will store the energy in the form of magnetic field. It will store the energy in the form of magnetic field. Okay, resistor will dissipate the energy in the form of heat. Inductor will store the energy in the form of magnetic field. And inductor means it is the property of the material. It will oppose the sudden changes in the current, and it will store the energy in the form of magnetic field. Now, formula for the inductance of any coil is given as mu n square A by L. Small l, let it, mu n square A by L Henry. Okay, the units of inductance is Henry. Okay, so the symbol of inductor is like this, L Henry. Mu n square A by L. Here mu is the permeability of the material. Sorry, permeability. Okay, this can be written as mu is equal to mu r into mu naught, where mu r is relative permeability. Relative permeability. It depends on the type of the material. And mu naught is the permeability of free space. Permeability of free space. Mu naught is permeability of free space, and the value is 4 pi into 10 power minus 7 Henry per meter. 4 pi into 10 power minus 7 Henry per meter. And N is number of turns. And A is cross sectional area. And L is length of the inductor. Length of the inductor. Okay, this is in meter square, this is in meters. Now consider a simple circuit. If we apply a time varying voltage, then a time varying current will flows through this inductor. Then flux is produced in this inductor, let it be psi. Okay, here production of flux is directly proportional to current passing through this inductor. Okay, so if we replace this proportionality with constant, that is L, this is L into IL. Okay, let it be IL. Now the voltage across the inductor can be written as VL of t is equal to rate of change of flux. Okay, so substitute here this value d by dt of L into IL of t. So what is VL of t? VL of t is equal to L into dIL of t by dt. Okay, this is the voltage across the inductor. This is the one of the form of Ohm's law. Okay, next one, we get VL of t is equal to L into dIL of t by dt. From this expression, write IL of t. So IL of t is equal to 1 by L into integral 0 to t VL of t dt plus IL of 0. Okay, this is the initial current or current at t is equal to 0. Now power stored or power absorbed by the inductor is equal to VL of t into IL of t. So P is equal to VI now. So what is VL of t? L into dL of t by dt into IL of t. So what is the power? L into IL of t into dIL of t by dt. Okay, this is the power. Next, energy stored. Energy stored in a inductor is equal to integral of power, integral p dt. So substitute this value in this equation, you will get L into IL of t dIL of t by dt into dt. Okay, this dt cancel. So if you integrate IL of t, what you get with respect to IL of t? So IL square of t by 2. Energy stored in an inductor is equal to, this can be written as half L IL square. Okay, you can write IL of t whole square. This is the formula for energy stored in a inductor. This is in joules. Okay, next element is capacitor. So it is denoted with C. So the definition of capacitance is, it is the property of the material which oppose the sudden change in the voltage and it will store the energy in the form of electric field. Okay, it is the property of the material which oppose the sudden changes in the voltage and stores the energy in the form of electric field. Resistor will dissipate the energy in the form of heat. Inductor will store the energy in the form of magnetic field. Capacitor will store the energy in the form of electric field. So what is the definition? It is the property of the material which oppose the sudden changes in voltage and it will store the energy in the form of electric field or electrostatic field. The formula for the capacitance is epsilon A by D. Epsilon A by D. So units are farads and the symbol of the capacitor is like this, C farads, where epsilon is permittivity. This can be written as epsilon naught into epsilon r, where epsilon naught is permittivity of free space. Permittivity of free space, and the value is 8.85 into 10 power minus 12 farad per meter. Next, epsilon r, relative permittivity. This depends on the type of the material. Relative permittivity, and area is A is area of the parallel plates. D is distance between D is the distance between these two plates. Okay, same. This is meter square and this is meters. Okay, again consider a simple circuit. So this is the capacitor C with capacitance C farads. If we apply time varying voltage, time varying current is flowing through this capacitor. So here on the top of the plate a positive charge is accumulated and bottom plate a negative charge is induced. Okay, so this charge is directly proportional to Q is directly proportional to this applied voltage. Okay, this Q is directly proportional to applied voltage or voltage across capacitor. So to remove this proportionality, we replace some constant, that is Q is equal to CVC. You can write Q of T is equal to C into VC of T. Okay, now current flowing through the capacitor is, so that is IC of T is equal to rate of change of charge. Substitute here Q of T. So this can be written as IC of T is equal to C into dVc of T by dt. Okay, this is the current flowing through the capacitor. This is the one of the form of Ohm's law. We get IC of T is equal to C into dVc of T by dt. Okay, from this expression write Vc of T. Vc of T is equal to 1 by C into integral of 0 to T IC of T dt plus Vc of 0. Okay, this is the voltage across the capacitor at T is equal to 0 or initial voltage on the capacitor. Next one, power. Power P is equal to Vc of T into IC of T. So what is the power? What is the Vc of T? Vc of T is same. What is the IC of T? C into dVc of T by dt. So power is equal to C into Vc of T dVc of T by dt. This is the expression for power. Next one, energy stored in the capacitor is equal to, so we know that integral of P dt. So power we get in the previous expression C into Vc of T into dVc of T by dt into dt. So this dt gets cancelled. So if we integrate this Vc of T, what we get? C into Vc square of t by 2. So what is the energy stored in a capacitor? Ec is equal to half CVc square or Vc of t whole square. This is also joules. This is about the resistor, inductor and capacitor. In the next video, we will solve some problems on this topic.